Good afternoon, Deepak. Good afternoon, everyone.
Good afternoon, sir.
Good afternoon, Devanshu. How are you?
Fine, sir. How are you, sir?
I'm good. I'm good. Thank you. So yes, all of you are here. So in today's class, I'm just going to share some application part. Okay. Yeah. Good afternoon, Kusha. Application part of this process modeling, simulation, and optimization. Mm, Today morning, I had received one mail from IUCE. Just give me a minute. Where it is? With MATLAB, they have 2 days consortium, and that is MATLAB Expo. Yeah. I will share a copy of mail itself, and yeah. So today we will discuss about it. That means how we can deal with it. Yeah, is this visible? Right? So it is a foundation Indo-Universal Collaboration for Engineering Education, IUCE. So the knowledge partner is MathWorks, that is MATLAB. And they're having this Expo, MATLAB Expo 2021. I don't know whether it is in the online mode. I'm just trying to copy this in your chat box. You please try to click on it, Deepak, Devanshu. Whether it is no, it is not coming. I will share with it. Don't worry. And this is free of cost. Okay, so we'll try to look after it whether it is. So this actually it is the part of our discussion for this course process modeling simulation optimization. It is not working. I don't know. Since we had to deal with, I think I'm having some network issue, connectivity issues. What is this? Yeah, this is open. This is open. This is open. I'm going to share window with you. I don't want to minimize. Is this visible now? MATLAB Expo. Deepak Devanshu. Is this visible? Yeah. So I feel this is important for us because MATLAB is very important in our course and in our day-to-day life as a chemical engineer. So these are the agendas of this expo, where you can exchange your ideas, deepen your knowledge, you can build the relationships with the industry person, right? And they are having a kind of uh, proceedings as well. To be frank, I am going through this second part of this website first time. You can go through it. I will share the link with you and see they are providing trial software as well, right? So if you are interested, you may go through it. What exactly the why it didn't call for submission? Screen highlights. Let's check. So will you please write what we have discussed in the earlier session? Can you remember what we have discussed in the earlier session? Will you please write in the chat box? And you can submit your work to math work as well. Steps involved in mathematical modeling. That is what we have to do it here. Okay, this is what we have to do, nothing else. So if you'll go for registration, I don't know whether it is showing the, I think it is. These are the plenary session. We'll go through it. That is very important. Various term involved like dependent, independent variables, manipulated variable, right? So these are the plenary sessions. So see, like artificial intelligence interaction between natural and artificial intelligence. By the way, he is from Max Planck Institute of Brain Research, one of the renowned research center. Then electrification in the aerospace industry. If you are interested, Dr. Amit Gupta, he's from Rolls-Royce Singapore Private Limited. It is not private. Now, what is the meaning of this, Devanshu? Are you aware about this? PTE Ltd. Will you please check it? What is the meaning of PTE here? Rolls-Royce Singapore PTE stands for. I'm not aware about it. Then related to the 5G interdisciplinary word, that is very important. Scientists and engineers save the world. Okay, he's from MathWork itself. And what is new in MATLAB and Simulink 2021A? So you may create your own agendas for modeling and simulation. This is what is very important. Now that this is what we are discussing and in which we are interested. Okay, modeling and simulation. These are the hosts for the Tech Ignite session. You may register for it. I will share the link. If you go for the agenda, full agenda, will it be after registration? Yes. So this is the agenda where 5G and radar is from IIT Kharagpur, right? At 11:30 a.m. Then from NVDI, University of Naples. NXP from Bosch, right? Mercedes-Benz, European Space Agency, Renault Nissan, Airbus Helicopter, HEO Engineering, CAF Power, AB Volvo, General Electronics, GE. So this will be helpful for us to create, to build our links as well. National Physical Laboratory, Stanford University, Luxato, Mercedes-Benz once again. Okay, this is region wise. This is region wise. So this is IST, right? This is day 1 and day 2. Day 1 and day 2 for us. start in India at 9 a.m. up to 12:30. Only 3.5 hours a day, and remaining will be on the third day, 9 a.m. to 12 p.m. So sessions, and this is what is very important: networking plus exhibition time. Okay, so if it is online in the online mode, we may take advantage of this, right, Devanshu? I'm going to share the link with you. Yeah, please let me know whether it is working or not. Yeah, please check it. Please let me know whether it is working or not. If you're interested, you can register for the same. I'm also registered for it. If you are interested, you can do it right now. I will give you 5 more minutes to register. Is this working? Devanshu, Deepak, Kusha.
Yes, sir, it's okay.
Okay, fine. Okay, if you are interested, you may register for this. Okay, you may register for this. If you want to register right now, you can register. Okay. Start the discussion for the remaining part. In the previous class, we had discussion about models, the steps involved in it. And today, if I'm not wrong, we'll discuss in terms of this is 2021. No, 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 no. We discussed in terms of the parameter variables. And then we'll try to discuss some more points related to this. Classification, we done with this. So I think almost, discussed today in terms of, yes, this is what we had discussed in the earlier session. Oh, it's not visible to you, right? This is now visible, right? These are the steps involved in the mathematical modeling process. So the first one is state of the process, and we have seen that for model development, we must deal with these three phases. The first one is identification, then analysis, and the governing equations. Right, this we have discussed. Next, classification based on the state of the process, the variables, input and outputs, some parameters will come into picture. But the terms involved in it, as suggested by the Devanshu, we discussed in terms of control variables, manipulated variables, okay? So which changes with the progress of process, it is known as control variable, and directly affect observed in the process or in the course of the process, and can be measured and changed purposefully. So those variables are known as manipulated variables. Then what do you mean by disturbances? Disturbances, it is nothing but the variables that directly affect the course of the process, but that cannot be changed purposefully. Okay, that cannot be changed purposefully. So it is referred as disturbances. Then intermediate variables, variables related to the course of the process only indirectly. Okay, so this is intermediate variables. The third one which we have discussed, the step number 3 is identification and establishing the relationship along with the constraints and boundary conditions. Okay, so the static model of a unit process should allow for the possible modes of operation of the typical reactor. So that is the step number 3 which we have discussed. Let us discuss in terms of dynamic model. Right, what do you mean by dynamic model? I hope you are aware about it right now. Dynamic model, it is nothing but when the variables or the main variables or the relationship, whatever you have in that particular model, that is going to be changed with respect to time. That is going to be changed with respect to time. That is known as dynamic model. Okay. And you may aware about that the dynamic models are somewhat difficult to work upon, or they may be quite difficult as compared to the steady state models, because you have to write d by dt. Something is changing with respect to time, so it represents the dynamic characteristics of the process. So these dynamic characteristics may be obtained by theoretical approach, by the experiments, by conducting the experiments, or both the processes, right? Either maybe by theory or by the experiment. And in this process, let's say if you have to obtain dynamic characteristics experimentally, disturbances are applied to the input of the system and the time response to the disturbance is noted. You have to apply the disturbance. What is the disturbances? We'll see it once again. Variables that directly affect the course of process but cannot be changed purposefully. Where the course of the process may get changed. So disturbances may be applied, slight change in that, and you have to note the disturbances. So what is happening with respect to time if you will change one of the parameter? So that is nothing but the dynamic process, and the change in variable may be referred as disturbance. And these kind of experiments are based on the law of signal flow dealt with in information arrayed control theory. So there are a number of control theories. This is what why I have showed you that MathWorks Expo, because this control signals how we can implement in the chemical industries. So that is very important. Okay. This is based on the dynamic characteristics. Okay, it is depends upon the dynamic characteristics. So dynamic models, you know how to represent them. Let us take the simple example for, you might have studied this and you may remember this. Okay, you please let me know. Deepak Devanshu Kosha, you had studied about transfer function of uh, first order system. Again, process control, you might have studied this. You had developed the equation. You had developed the relationship between the how thermometer will change its behavior. Yes, Devanshu, thermometer as well, right? So this is nothing but the dynamic response or the model developed for this. We used to write, if I'm not wrong, y of s divided by x of s, that is equals to g of s is equals to 1 divided by what is 1 divided by tau 1 x plus 1 or tau plus 1, something like that. 1 divided by tau plus tau x plus 1, something like that, right? So that is the transfer function. Transfer function, it is nothing but the ratio of Laplace transform of output function to the input function. Right, Devanshu, we used to write like this. Let me change this. G of s is equals to y of s, that is steady state, at x of s. Yeah, it is like 1 divided by tau 1s plus 1. Yes, I got it. This is the equation of first order system. Tau s plus 1. For second order, it is tau square s square plus 2 psi tau s plus 1. Right? It is something similar to that. So this is the kind of transfer function we have studied for different processes. So what is happening here? There is the change in process with respect to temperature, with respect to time. The important parameter is change in time, that is reflected as dynamic system or dynamic process. Okay. So let's say if someone is interested in the dynamic model, so what it is a set of transfer functions relating the selected dependent variables to one. Same one, that is what we have discussed here. G of s equals to 1 divided by tau s, tau 1s plus 1. Tau is the time constant, right? This may represent ordinary or partial differential equations. Those may be derived theoretically and containing all the necessary dependent and independent variables. Those are analyzed independently of one another, right? Those are analyzed independently of one another, right? So this is the function. This is the function. Okay. Next, equations derived for the various elements of the unit process that may be or several independent variables. Here I took in terms of tau 1 s plus 1. Next, you can say tau 1 square, tau 1 s square plus 2 sigma tau s plus 1. So there may be individual components, they may be dependent, they may be independent, and based on that we may take the addition of the remaining several independent variables as well. Okay, so this is related to the classification based on the state of the process. And the second point here for the discussion is dynamic model. And the subtype, one more subtype, depending upon whether given process is deterministic or stochastic, they are represented as an analytical rigid model, a numerical rigid model, an analytical probabilistic model, a numerical probabilistic model. Analytical and numerical, rigid and probabilistic. These are the types. These are the types of the classification based on the type of the process, right? So it may be noted that in some practical cases, the model cannot be classified under any of these. So the choice of the particular type of the model is to a great extent determined by the simplicity of the solution it offers. Actually, there are few examples, like let's say if you have to discuss in terms of Newton's method to determine the appropriate minimum or maximum value. Okay, you might have studied about this. This is given like this. X n plus 1 is equals to if I'm not wrong, f of x minus f dash of x. Please correct me if I'm wrong. I may be wrong here. F double dash of x. So this shows the behavior. This shows the behavior, right? F dash of x and f double dash of x. You have to equate the f of x with the 0 and you have to find out the particular solution. You have to find out the particular solution. So it depends upon the simplicity. You can simply do that by just finding out f dash of x, the first derivative, equating this with the 0 and find out your appropriate values of unknown. It shows how it will be good. Okay. So all these things are here. So sometimes general representation or by just looking at the method, how it is simple, we will be able to identify the process. Okay, is this clear? I hope you might be aware about this, but once again, we have to go through this. So what do you mean by rigid or deterministic models? These models usually describes deterministic processes without the use of probabilistic distribution. You are not going for the probability. Okay. And the subclassification of rigid or let's say deterministic models is analytical rigid model, as we have seen in the earlier slide, and numerical rigid models. It depends upon whether the solution is obtained analytically or numerically. Are you getting my point? Whether the solution for that particular process was obtained analytically or numerically, right? So this is discussion about rigid and deterministic model. And sometimes, yes, there may be some underlying phenomena. Let's say, if we are discussing in terms of characteristics, in terms of statistical models, statistical parameters, sometimes those statistical parameters may not contribute as per the requirement. So what is the performance? Sometimes it is overperformed, sometimes it is underperformed, but we want the exact values. So what you have to do at the time, you have to take the average. Okay, the distribution is not that much important there itself, and you have to deal with the average. Okay. So let us discuss in terms of stochastic or probabilistic model, which runs the stochastic, that means random here. And there is subclassification once again. Probabilistic model is analytical probabilistic and numerical probabilistic. Then depending upon whether the solution is obtained, it is same as like that of analytical or numerical. And simulation corresponding to the numerical stochastic model is known as Monte Carlo simulations. Okay, please do remember this about Monte Carlo simulation. If you are interested, you may go through it, what exactly the Monte Carlo simulations are. This is one of the topic where we can contribute to the system in order to perform the behavior of the system, how the parameters are changing. So Monte Carlo is simulation is very famous. And if you are interested, let us explore it. And if let us compare between rigid and stochastic models. So in construction of rigid models, let's say use of different classical techniques of mathematics like differential equation, integration equation, linear differential equations, and operators for conversion to algebraic models and so on can be used. And in probabilistic models, or let's say rigid models, distribution of discrete and continuous variables and also sample distributions can be considered. What is the advantage of statistical models? It's probabilities over the rigid, that means analytical one, is that these do not call for rough approximation and allow for a greater number of factors. This is the advantage. This is one of the advantage. Okay. And then sometimes these models are very difficult to analyze and grasp. So it provides less precise values. So it is, let's say, no, it provides accurate results, but due to its complexity, one may prefer to use less precise analytical models. Okay. Apart from that, the best results are obtained when both analytical and statistical models are used jointly in conjunction with each other. So it is the phenomena which is to be observed, which is to be studied in combination, right? So a simple analytical model will give an insight into the basic behavior of the prototype system and suggest further approaches in which statistical models of any complexity can be used. Okay, so there will be prototype system. You have to further approaches which provide the statistical models, and RTD models are good examples for this statistical base. Okay, as a rigid one. So next we have to discuss in terms of boundary conditions, what exactly the boundary conditions are. Okay, so let us discuss about it. Are you guys with me? Can you show your presence with the help of smiley in the chat box? Can I check your presence in the class? Can you show your presence with the help of smiley? Okay, Devanshu is there. Deepak is there. Okay, Usha, she is also there. Fine. So the next part for the discussion is boundary conditions. Okay, you please go through it. I will be back within a minute. Yeah, please go through it. Go through this slide. I hope you have gone through this slide and it shows what is the idea behind using boundary conditions. You might have used this at x equals to 0, x0, at t is equals to uh, capital T, it is capital T, something like that. So you guys are aware about the boundary conditions as well. Okay. Boundary conditions are very, very important since it provides complete solution for a particular set of problem. And these constants how to be evaluated. You might have studied about in terms of integration. Okay, there is a constant of integration plus c. We used to write that c. What it is for that plus c, you are going to put sometimes boundary conditions, initial boundary conditions or final boundary conditions. Okay. So these are the kind of dependent variables at the endpoints and of the range of independent variables as well. Okay. So these are the special conditions. And these are naturally called boundary conditions. These are naturally called boundary conditions. Okay. And yes, this is used to evaluate the arbitrary constants in the solution of differential equations. The one which we took the example, that is for integration, right? So next, how to get the complete solution of such type of problems, right? So to get the complete solution of particular problem, constants have to be evaluated. Then special conditions are placed on the dependent variables at the end of the range of independent variables, then these are naturally called boundary conditions. Okay, these are naturally called boundary conditions, and these are used to evaluate the arbitrary constants in the solution of differential equations. Right? This is very easy. You know about this, and you might have studied this, and you might have applied this. So one more question which may be asked in the exam or which may be in your mind: what is the meaning of initial condition? Though we have discussed in terms of boundary condition, but what is the meaning of initial condition? Okay, so when time is the independent variable and the boundary condition is frequently called the initial condition since it specifies the starting state of the apparatus. It specifies the starting state of the apparatus. So that is referred as initial condition. Okay, where the starting state, that is the initial condition, right? Next is you may be asked to list any three most frequently used boundary conditions in heat transfer. Let's say we used to write like boundary at a fixed temperature T is equals to T0, right? Then you may say that constant heat flow rate through the boundary, let's say isothermal condition, there is no heat flow. So dt by dx is equals to constant. And for thermally insulated system, adiabatic condition, no heat flow, dt by dx equals to 0. Okay, these two are common conditions. And the third one, you know that the boundary tool, sorry, this tool is used to discuss the film resistance offered to any system. So it is somewhat in order to provide the heat transfer coefficient, k into dt by dx is equals to h into t minus t0, ha delta t, right? So k is thermal conductivity, h is heat transfer coefficient, t0 is the temperature of the surroundings, right? So these are the three most frequently used boundary conditions in heat transfer. Got it? So this is the discussion for the heat transfer. Next, we are going to discuss in terms of black box model, gray box model, and all these things. But this we'll try to cover in the next class. Okay. Do you have any doubt up to this point? Any doubt, any suggestion? Please let me know. No doubt, no suggestion. Okay. So just to summarize what we have discussed, we discussed in terms of term involved here, like control variable, manipulated variable, disturbances, intermediate variables, then step 3 in the steady state modeling. Then we discussed in terms of dynamic model, right? Then what is the idea behind the transfer function, ordinary differential equations, the subtypes of deterministic and stochastic processes, right? And then the classification and it's what is Monte Carlo simulations, how it is constructed, where it is constructed, what are the advantages, how it is to be compared, what are the different examples. And then we discussed in terms of boundary conditions as well. Okay, so what is the general solution for it? So you can solve it, you can get the number of constants here, then it is evaluated to get the arbitrary values. I think we have not discussed this right today. Do we left this? Okay, this is general solution, like arbitrary constant, number of constants, special conditions will be there. These are referred as boundary conditions. Okay. So this is what we have discussed and what do you mean by initial condition that we have discussed. Okay. And at the end, we discussed in terms of most frequently used boundary conditions in heat transfer as well. Okay. So next we'll try to discuss in terms of black box modeling, gray box modeling, artificial intelligence, all these parts. And this will be the discussion. You may take snap of this. So this will be the food for thought to all of you. This is what we are going to discuss in the next session, and I'm looking for dynamic discussion from your side with reference to this image. Okay, but still, if you have any doubt or if you have any suggestion, you may write in the chat box so we can have a discussion. Okay, so no discussion, nothing, no doubt. So thank you very much everyone for joining. uh, Actually, I thought to ask this to you, Devanshu itself. Did you get your result? I don't know. They may be looking for it. Soon you will get it. Soon you will get it. Soon you will get it. If I'm not wrong, I will ask to the head of department and I will let you know. Okay. Because that is to be decided by examination section. Okay, then. Thank you very much, everyone, for joining today's session. We'll meet in the next class with the same link. Till that time, take care and bye bye. Thank you. Thank you. Same to you. Mm. Welcome, Deepak.